Okay. Hopefully we're live right now. Let's just double check. Yeah, okay. So, yeah, hello everyone. The idea here today is that I will continue to work on my programming language. I have been working on that for a while now. Let me basically show you guys how it looks like and what are the main ideas about it, what I want this language to look like, and what are more or less how it works. And yeah, as you can see, it's pretty straightforward. Basically, here you can see that the idea here is that this language is a compiled language, right? It's a typed language with a very strict type system, and yeah, so a strict type system, compiled language, but I do want to include compile time logic so that you can actually execute things during compilation step. So for instance, if you have multiple steps in your build process or whatever, and you need to have some conditional logic on what you need to do, depending on whatever is your requirement when you're doing your own thing, right? You can do conditional logic, for instance, like if some condition, you can do something, otherwise you can do something else, and depending on this condition, which is probably a compile time variable or something, you'd be able to do that. And if this is true, then only this part of the code would exist after compilation, and this other else in here wouldn't exist. Or depending on the condition, only the else will exist. So that's more or less the idea. And as you can see, the syntax is pretty much simple. We can assign values, so we could say like a variable a is assigned to 10. We are assigning a 10 to this variable a. We are inferring the type, but we could, for instance, say this is assigned 64 integer, or maybe we have some sort of unsigned value, and this would act like a define in C, so something like define a10. They pretty much look like the same thing, in the sense that a cannot change because of the type of assignment that we are doing. It is a define. But one of the ideas that I have is that eventually at compile time we can change this. So if we have like I don't know, we can say like b is, we can have a condition, right? If some condition in here, and then we have a value here, otherwise the value is like 10 or something, and then we can say like b is 20 actually, and then a equals to b. That would work because this is happening at compile time, so this is a option for whatever reason. What else? Yeah, so this can change because we are using an equals in here. We are inferring in type, and then we are assigning a value, but this value can change over time. So we could say value a is actually 1, and that would work. And we can also, I don't know about this, probably this will not be a thing. Maybe it is, I don't know. Either way, we also have functions, or in this case I'm calling this procedures, right? And they are pretty much an assignment of a lambda function or something like that. This is a function without a name, and because we are assigned this to some variable, this becomes a function. Basically, that's the idea. And we are inferring that this is a function, but in theory, we would have something like a proc or something in here. I'm not really sure what I want to do in here, if I want to include the inputs and outputs and whatever. But for now, this is inferred. One other thing that I was thinking about is that the actual signature could be the type of the function, so this is something that actually would work, but I'm not 100% sure yet. And everything else, works as you would expect. So this is how you would call a function. This is how you initialize a function, and then we can assign a value to the function. We have operations in here. So plus, multiplication, we could include division, greater than, less than, whatever. Everything can be called inside of a function. So as you can see in here, we have a function with no inputs and no outputs in here. We are assigned to this binary ops variable that becomes a function, and we have this is not called a primitive, but I don't remember the name right now. It's an intrinsic, actually. I think that would be the name, because this is technically a function, but actually this is a keyword in the language. Later I probably will remove this as a keyword and would have something like exit, and then you can specify the exit, the status code, and then you can include some sort of message that is related to that exit status. You can also see that I'm not using quotes for defining strings. I'm using these symbols right here to initialize the string and to finish or end the string here. And this is a string. In theory, we could pass here some sort of bin op, for instance. Then we have a string interpolation. This is not implemented yet, but eventually this will be how we interpolate strings. What else? Yeah, and why I'm not using quotes for strings? It's basically because I want to use double quotes for errors. So for instance, it's not implemented yet, but the idea is that eventually we could have something that can error out, so operation that fails or something, and then we could say that it accepts some value that is a string or something, and it returns another string, but it can fail, and we can specify that it fails using the exclamation mark. And eventually we could have some sort of a bunch of operations in here, and because whatever reason we have an error, we would return the error, and would be some whatever error that made this function fail. And another thing that someone would be able to do is actually include the reason for that error. So this would be like the return type, or not the return type, the return value, and this would be like the description, so failed for whatever reason. And eventually someone would be able to do something like, okay, if the operation fails, right, we can pass here whatever, and it may fail. So if it fails, we could catch that error. So we could say like, this is the error, and we say unless the error, and then we can handle the error. And because we are catching the error using this variable here, we could say something like error dot reason for instance, and then we could print that for some sort of logging or something. I don't have any API for printing or anything right now, but this is a use case. And reason would basically be anything after this comma. So everything here would be printed. And in theory, we could also include here any string interpolation, because technically this is considered a string, right? Only this part, everything before the comma is just a value that would be eventually replaced by something, I don't know right now what I want to do about it. Maybe it's a number, maybe it is something else. I don't know. So yeah, this is one way that I'm thinking about handling errors, because I actually do not like how most of the languages today handle errors. So I don't like Go error handling for now. I don't know if they ever will change that, but for now I really don't like it. I don't really enjoy how Rust does that as well, because they have the option and result, and that's super fucking annoying. So I don't know, I don't like it. So going back to Go, actually, right, I do like that the error is a value that you can check, but I don't like how you need to check that. I don't like the if error is equal to nil or something, or not equal to nil, then that's an error. Otherwise, continue. Sorry about that. So I think what I was thinking is basically I want something that is a value like error, but with better handling, which made me think of something like this. We run some operation, whatever that operation is, unless there is an error, and the unless is basically the if error is not nil or something, and we are catching the error inside of this variable that is called error, and then we can use inside of a scope. And this is one way to do that. The other way is that maybe we have something like operation. Let me just copy this, and instead of failing immediately, we just infer the type to be a string with a possible error. And if you want to do something like Go for whatever reason, you could do something like if catch a, and then you can, capture that error using the same syntax as before, and you would be able to do that the same way. And also, if you don't want to catch the error, you can, if you have an error, you just return the error, because you don't care about it. Maybe another function will handle the error for you. One option that I am thinking about is basically having let me copy this for the sake of making things easier. Instead of checking for errors, we just say, okay, I don't know if we will fail in here, so if it does, just return the error. And it's up to who calls if this function. So let's say we have something like proc, and then there's a function in here like d or something. Is responsibility for anyone who calls d to handle this error. So yeah, this is more or less the things that I thought about errors, because I don't like how Rust does that. I don't like how C does that, because C uses ints and it's kind of annoying to do that, or error no, and it's a whole thing. I don't like it. So yeah, that's more or less the gist of this language. It does compile right now, so I can show you. I do have the tokenizer and then the AST being generated. So if we do something like this, it will generate the AST for the entire program. As you can see, it's quite big. There's a lot of things that I could do to improve this, and eventually I will. So yeah, that's more or less about it, about this language. I do have other plans for it. Sorry, I was drinking something. So I do have plans, other plans. I do have a whole folder, a whole directory just for the language design itself, with a bunch of different things that I was trying out to make sure that I actually like the language. So here, for instance, is a somewhat decent eventual implementation of a hash table that I think will look okay, but there are things that I don't know if I like it or not. So, and here is what I was talking about, the error. So we are trying to allocate something. If it fails, then we return the error or whatever. I do have this idea that maybe I want to have some sort of method, but I'm not 100% sure. I need to think about it. But that would be more or less how I would implement that in the language, or maybe something like this, which basically says that we are implementing this function for this type, but I don't know. There's a lot of things that I need to do before that. So, what I want to do today. Basically, I want to type check whatever I have right now, because everything that I'm doing here is not type checked yet. So if I do something like this is a signed 64 and I am assigning this to, maybe let's do it like this, and then I'm doing a unsigned 64, that will work, and I don't want this to work. So it works, there's no error, and I don't want this to be a thing that is possible, basically. So that's the plan. Let's start with simple identifiers and literals, and then work towards functions, and then towards binary operations in here, because I want to make sure that binary operations are only allowed between types that match. So what does that look like? I don't want to have something like maybe C is 10 and then D is like 1.0, and then we have E equals to C plus D. I don't want that to be a thing. So this is inferred. The language is smart enough to know that this is a signed 64 and this is a float, so it shouldn't allow this kind of operation because the types don't match. And if eventually someone wants to do something like this, they first need to cast this value to something that is allowed. So maybe something like SU64 or something. Sorry, as S64, because this is the inferred type, and it would work, but at least this is explicit enough for people to understand what is happening. One thing that I do want to allow eventually is that if we have a function like whatever, and this function accepts an input that is of type void star or something. So if we have something like this, the idea is that I will allow anything to be cast into a void star because it's useful. So if we had something like a is equal to 10 and we would do whatever, and we pass 10 and we pass that as a pointer, that would work, because I feel like this is useful for us to be able to cast a type that is known to a pointer that has no type, and then we can do whatever operation. But yeah, it will take some time until we get there. So this is the idea. Let's get going. So I do have already something for type checking, but I think I will rewrite it because I don't really like how it is working right now. So, but before that, let's go into the actual EST because I need to update how I'm handling the program. So basically here we have all the files, and here we have the entire, steps to compile this program. And in here I tokenize everything. There's a whole how many lines we have in here? Yeah, 500 lines to tokenize that program that I had shown before. So that's okay size, I guess. There's some things that I would improve in here, but that's okay. And after we finish tokenizing everything, we are basically passing all the tokens to this function that is creating the AST, and the AST at the end will generate a program. But I don't really like how I am doing this right now. I think I will change that. Instead of using a program, I already have these allocated vars and procs at a global level, so I don't think I will need them inside of a struct, at least not right now. We don't have scopes for functions. We don't have allocated variables into specific scopes inside of a function. It's all global for now because I don't want to think about it right now. So the first thing that I want to do is basically remove that. Let me allow this, and basically we need to return a slice of nodes, and I need to instantiate a new slice. And I created this slice, and I'm not using Go because I don't want to use Go slice because I want to do my own thing in here. And basically I need to pass the count and the cursor, actually let me do the following, because this is what I will do at the end. Right now I need to do a node, a list of nodes that I'm going to append, and later I will have the program. So these are the nodes. These are the nodes. I am appending all the nodes, and I don't need this because it's no longer a struct. I can just simplify this, and at the end we'll have a program. And I think I can even do something like I will return that as a pointer. Then we can just do this using a node, and then we can say that the actual data, I think it's the name, I don't remember what is the name. Yes, data is actually nodes, and then the cursor, the count is the length of the nodes, and cursor is 0 right now, and we need to return the pointer. Yep, I think that looks alright. Let me see. Yeah, so it doesn't like that because CodeGen, and I need to update that. So let's go into CodeGen, and I will comment it out because I don't want to handle this right now. It's annoying. And also type checking, but we'll rewrite everything in here. So fuck that. And we can remove that just to see. And we can delete this because I'm not using it right now. Okay, sounds good. If we go into type check now, how should I'm calling this type checking. So let me do that. So this is the function for that. We are expecting a program, and this is basically a bunch of nodes. What the fuck? KU slice, and then it's a bunch of nodes, and it's not returning anything because it's just type checking. So I want you to think about something right now. Do I want to... Yeah, I think I don't care about it right now. I was basically thinking if I want to separate the type inference from the type checking right now, but I don't think I want to, because that is too much work for me right now and I don't want to do that. So yeah, I don't think I'll be doing that right now. Let's start simple then. Yeah, let's start simple. Let me go back into the AST and I want to look into this in here. So yeah, I think I can do that right now, just in case for whatever reason there's something that is incorrect, we can just catch it immediately. And then after that we need to basically loop, I guess, and we need to do something like what I'm doing right now in here, something like this, but instead of tokens it would be program. So cursor is less than the program count, and then we can do whatever we want in here. And now we need... So let me start slow. Let me go back to the testing, and what I'll do right now is basically comment out everything, and I will only work with this. So yeah, let me just work with this. And what I want to do, how I want to do that actually. So if I go in here, yeah, I don't care. So in here I need to do a new comparison function, so that would be node type comparison. And we are expecting something, we don't care about it. We are expecting something else, we don't care about it, and we are returning true or false depending on that. The first thing that we get is the node, and then we do a cast assert, and we are expecting a node from the value, and we are expecting a node type from the compare. And we are basically returning the node type if it matches. I think that's the idea. Yes. So then we can do something like if CS match, and then we are passing the program, we are passing, what is the name of the thing, this right here, we are passing this, and then we need what do we need? If it is a identifier, yes. So node identifier, if it is that, then it is good. So I can close that, and we can just, let's see if it works. And also I need to include that in here. And I think I'm passing that as a pointer, if I'm not mistaken. Oh, I am returning that as a, okay. Yeah, I forgot something. I need to consume the program. Yes, it reached. And also let me remove these right here because I don't care about it right now. Yeah, okay. Let's go back. So we got an identifier. And we got the type for that identifier. And basically that's it for this case, because we don't need to do anything in here technically, I think. One thing that we do need to do actually is see if the type that we got from that identifier, so if the if the type we define in the identifier matches the value, because not all values match identifiers. In this case, 2 can be signed or unsigned, and that's about it. Yeah, so first thing we need to get cs get, and if I'm not mistaken, let me do different, cs consume assert, and I need to specify the consume assert for this, which is pretty much what we have in here. But we are asserting it, right? Yes. Yes. And in here we need to do the same thing that I did in here for the return type, but instead of just that, I need to print something in case of an error. And I don't remember if I have a function that prints the name of the thing. Maybe, let me see. Yes, it is toString, and that's not what I want. That's more like it. Let me so it should be something like node type toString or something, and I am expecting a node. Am I expecting a node? Let me check. I am expecting that node type. Okay, node type, and then this is the node type, and I'm thinking it's a value that I'm passing. Yes. Where am I? Fuck. Here. So in here, let me change that. It will freak the fuck out, and we can basically just change all of them to match node type. and we need to return a string. Okay, so let's go back to slice, and in here we have no type to string, and then no type, and instead of this we are basically passing no type. And this is not value, this should be a, this should be. And why is it complaining? Oh yeah, okay, this is no type. Good. Now let me get this and go to type checking. Basically we need to pass the program, we need to pass this, and then we need to pass node identifier, and this is the identifier, this is, yeah, this is the actual node, right? Yes. Because we are only getting, yeah, so that's it. We can even double check that this is the actual node. Oh fuck. Yeah, I don't need that because I already, yeah, okay. That was just in case. One other thing that I can do, just for the sake of not crashing everything, we can just continue, and that should be working. Yeah. Let me drink something. So now we have the node. What do we need to do? I feel like there should be another function that checks. What do I want to do now? Because what I need to do, basically I have the identifier as this right here. We have a type that is this right here, and then we have a value that is 2. And I don't really care about the value right now because this is a literal technically, so this would be, this is an assignment, so I don't care about this right now. I only care about these two things. And I know this is a int literal from tokenization and creating the AST. And I know this is a this is a type because when I am building the AST, I can distinguish that. So basically I need a function that accepts the type and the value, and if they are allowed and we have some sort of list that allows them to be compatible or something, then we just return true or something. So how can we can do something like type allow value or something, I don't know. I will think about the name later. And in here we have the actual So this is annoying because I mean, not really. What we can do is basically like this. We get this, we allow this value here. We check for a value and we distinguish them between int literal or string literal or whatever literal. And then with that value, we pass a list of allowed types for that given value. Because a literal by default, we don't know. So let's do something like this. If consume, I want to basically I need to match them. So maybe let's do a little bit differently. This is the node, and if the node is of a type no, we already know it's an identifier, so this is the node. So let's get the value. Is basically node dot literal. Yeah, we have the value now. So type check the value or something. And we are basically expecting a literal, so we can say literal, it's a literal, it's a pointer, you know, it's a pointer, and then we can say that these are the allowed types, which can pass as a variadic value, I guess. Allowed types or something. And they are basically tokens, I guess. And we return a bool. I think that's the idea. Because then what we can do is if we have this, if we don't actually have this, we can fail, we can assert or something, and then we can just pass the value and a token that represents that specific type. So if we had something like I allow just the token, and then I can say the symbol is whatever, S64 or something for now, and then the token type is, I don't remember the token types. Yeah, token identifier right now. If we find it, then that's okay. Let me purposefully fail in here. And it failed, so it is working. And the idea now is that I can check, I can pass a list, not even a list, I can pass a bunch of types that are technically allowed given a value. I think that's the best approach. And another thing that I can even do is if value dot, let me do cast, and I can say this is a integer and this is the value, and I can say value and okay. If okay, then we can do this, otherwise we can continue because it's another type, which can be string float for now, or boolean, I guess. And if it is an integer, then we can say all the different tokens that we are allowing. And to make that even easier, I could say something like, we can create a helper function that generates tokens that represent their oh yeah, it doesn't work because I forgot to actually implement this fucking thing. So we need to actually implement this. So let's go. We don't care about the index. This is the token, or this is the type. In the allow types, and now the thing is, yeah, that's not the correct approach actually. So if it is an integer, and I know it is an integer because I double checked, in here we need to pass not the actual value, we need to pass the actual type that is specified. So var type or something. Yeah, so, and actually in here we need to do something different because this is a var declaration, and then assignment, and then literal, and then, yeah, now it should work. I was doing it wrong. So yeah, now we have the variable type, and then we can say that this is the var type, and the var type needs to match whatever we have in here. And this is not this, it's var type, and this is a token, and we can say that we can basically have a result, and if the allowed type is equal to the var type, we can just break result is true, break, and then just return the result. And we don't even need to pass that as a pointer, I guess. And we don't need the value anymore because we don't care about it right now. And now it should also fail. Cannot indirect. What is the issue? Oh. It worked when it shouldn't. So what did I do wrong? So I don't care about this warning. What did I do wrong in here? Because it should have failed. What is happening here? And then we need to compare the symbols actually. No. Is not even reaching for some fucking reason. Am I casting something that is incorrect? Yes, I am, because it is an integer dot value. That's why it is working when it shouldn't. No, it isn't. What? His result. Okay, what we have in here. It's true. So it should be working and it is okay. It is reaching here. Yes, it is. But this... we can't even... No, I don't get it. Because if it is true, it should be failing. No? Because it is in fact reaching here, in theory. No, it isn't, because why? So this is true. Oh, because I am stupid. And then we can just remove this and it should be failing now. Yes. Okay. So now it should work fine. Great. Okay. So now that we have that, basically should be an error message or something. So maybe something like we were expecting. So the thing is, we are expecting a lot of things. But so let's do something simpler. So and then we can say this, because right now we are going to use this in the error message. Expected a type of signed or unsigned integers. But God, for now let's not give the entire list, because that's annoying. But we got whatever that is, which is this right here. So, oh yeah, because fuck you. Let's test that. If we pass for whatever reason a string here, it should fail. The value 2 expected a type for signed or unsigned integer, but got... Did I? Yeah. And I don't think we need a new line here. Yes. And also let me do the following because it's annoying. I don't want any debug information right now. I just want my own kind of thing. So yeah, so we failed that. Great. Now let's go back. And this is a signed 64. Okay, now I will just make the helper function because it's kind of annoying to do this kind of thing in here. This right here, I don't want to write this all the time. So how can I do that? Make type list or something. And this is basically just a list of tokens that I can use for whatever. And every single token will be identifier, so I can do whatever I want later. So this technically doesn't even matter, I guess. But just for the sake of consistency, I'll keep that as an identifier. So yeah, let's ask for a bunch of type symbols. They are just a bunch of strings, and then for each of them we just we append to the token list, so we have a token list. And we can just loop through them. I don't care about it. And this is the token, this is the string actually. Type symbols. And we are appending in here a token, and this token has the symbol string, whatever that is, and then the token type will be identifier, just for the sake of completion or something, I don't know. And then we just return that. And now it is easier for us to just create whatever we want. So we could have something like allow types or something. Make type list, and we can just say that it's a signed 64, and we say that this is our yeah. And it works. So we can even say something like, okay, not only signed 64 but also unsigned 64, and it should work. Let me change that real quick. Yeah, it works. And we can have the whole list of things in here. So there are other types as well for signed and unsigned. So signed 32, signed 16, and even signed 8. I think we have. I want to include signed 128, but this is not a default behavior, so I don't know. Let me see if I have that. Yeah. So it is working, and we can double check that the type is correct. So yeah, let me also do that for unsigned, just for the sake of completion. And we can just have unsigned. Yep. So these are the allowed types for this specific value. Yeah. Which is great, I guess. We can even remove this because who cares? We're no longer debugging, no error, so we can even check. Yeah. Now let's try identifiers, because they are a whole different type of thing. And I think I can even do something a little bit different for how could I do that? Let me double check something. So assignment is a node. Can I do something like node type is equal to node int literal? Can I do something like this? I don't remember. Yeah, I deleted something that I was not supposed to. I guess so. Yeah, so I think that is better actually, because then we know the type of assignment in here, and it's easier for us to just say something like int dot value, and we can just cast the value instead of this whatever I had before. And then we have both the type and the value for that, and should be working as expected. Yes, great. Okay, now let's test. Let's try actually with value b, and let's say that this is a U64 and we are getting these right here, and this is very much different, because now instead of a token, instead of a node literal, we have a node identifier, so we can check for that. And we have a continue, it should be in here instead of there. And here we can say a continue as well. And instead of literal, it's identifier, which changes quite a lot actually. So before we had this right here, and now we have something different. We have the identifier, which is value b, We have a type that is of unsigned 64, and we have a value that is an identifier. So the thing is, we don't care about this. This is just the assignment. We care about this and whatever type this is. So in turn, what we need to do is basically we need to get the type of this, and then we need to compare this type with this right here. Okay, let's try it out then. So in the assignment, we have a node, and that node is a variable declaration. I don't actually remember. Let's double check, because I have no clue what the fuck it was. I don't remember. Value A, whatever. Reassignable false, yes. Did I make a mistake in here? I think I did. No. What do you mean? Because it should be value B, and we got value A. Did I not recompile or something? Huh? So we get the node identifier, then we double check to see whatever we have, and the assignment should be this. Huh. What do we have in the AST? This is value A. This is value B. So it's not reaching, is that an issue? Did I make a mistake or something? No. What? What is the var declaration? Oh, it's because, okay, I see the problem. I am just stupid. So this is the variable declaration. Yeah, this is this is different because we have an identifier. We need to see at the declaration level. Yeah. So this actually is the variable type. So this is the var type, and this is the type. And that should be, yes, uses, yeah. Okay. Now that we do have the type, so this is technically the left hand side, right? This is the left hand side. We have the type for that, and now we need the type for the right hand side. So let me left hand side var type, and I do not have any kind of differentiation between left hand side and right hand side right now. In the technical perspective, the theoretical whatever, I'm just calling things by their name. I mean, I'm calling things as I see fit, not that this is correct. Now that we have the left hand side type, now we need to get the value. Now the type from the value of the identifier, which would be something like var declaration dot assignment dot, then we would have some sort of node type as well, and then depending on the type that we have, no, actually no. What do we have in here? Because these structs, they are so big, I don't remember anything. I fucking hate this garbage language with the unused variables as a problem for you to compile the language itself. Oh my fucking... So we need to get the type of the assignment, right? Yes. So var declaration dot type. And we need to do basically the same thing now. We need to do the type checking, but instead of having a list of allowed things, we can just use the one thing that we know is allowed. So we can even say right hand side of the var. And then we have that, and we can just say left hand side and right hand side. What is the problem? Yeah, okay. And basically we can assert false as well. For now I don't have any error handling or anything for messages. So we need the name as well. So identifier is basically this. And then the symbol. So the identifier whatever expected a type whatever but got whatever. So this is identifier, and then left hand side dot symbol, and right hand side dot symbol. Did I misspell it or something? Yeah, identifier with an I. It should fail. Identifier value B expected type U64 but got S128. Nice. And if we change this to U64, it should work. It is working. Nice. Okay. So we do have something working right now for type checking. I just need to make sure this, I hate using this. There probably is a better solution that I need to think about. But not right now. So now let's do something a little bit different. Let's have type inference right now. So this will fail probably. Yeah. Because we are not providing any sort of type, which is okay. But we need to infer the type, and that type inference should be before, I guess. I don't know. I think I'll do it at the same time for now. Later I can just have a step for type inference and then a step for type checking. But for now I think that's fine. Yes. Yeah, I think so. And if I'm not mistaken, we do have a token type to infer. Yes. So what we can do in here is basically the following. Before we do whatever type checking, we can just say if our type dot token type is equal to token infer. We now specify the type beforehand. And since we know this is a int literal and we are inferring it, the default value for, the default type for a integer in this language should be assigned 64. And we can just say that, I guess. So var type is actually a token with a symbol of S64. And the node type, not node type, the token type should be token identifier. And then we can continue working. And I don't even think we need to type check anything after. Because we are inferring the type. Yes. And now if I do something like this, and assign value, it should fail. Yes. What is happening here? Expected type U64, but we got whatever. Huh. What? Why is not working? Var type dot symbol. Oh, I think I know why. Yeah. This should be a pointer, I guess. Or maybe even... Huh? Yeah, and also just to make sure that we don't have a lot of indentation. Continue. It's easier like this. Oh. Mm-hmm. So the problem is in here. Because why though? I don't understand. What the fuck? So what we have the value, we have assignment. Oh yeah, it's a literal. That's why it is not working. That's why we need to make them separate variables, I guess. How can I handle this? Yeah, this for sure needs to be split up into other functions that we can call. That would be like, okay, parse or type check identifier, and it will do everything for us. And then we have another thing that is for integers and so on and so forth. How can I do that quickly just for the sake of testing? I don't really know. Let's... What do we have as an assignment? Let's see. Okay, let's debug this. What we have in here? We have a value assignment and assignments of type 2. And then we can say basically what is true is in, yeah. So let's do it like that. I think it's easier. If node type is node identifier. We do this. Otherwise, we have like, I don't know, int literal. We do something different, and then we can say that this is like not a var declaration, this is a literal this is a declaration type. No, wait a second. What? It is used. Oh, I see. So what we have, it's an assignment. Not this. This is yeah, that's when we need to yeah, I think I know the problem in here. That's where we need to start looking into the allocated variables, because we don't really have access to that for yeah, that's annoying. So what I need to do in here is, in addition to setting the variable, yes, we need to get the allocated vars, and then I need to get this right here, dot name dot symbol, yes, and then I need to get the yeah, let me see what we have in here. This is a node. Yeah, so we had the value, we don't have, so we need to get the var declaration for that, and then the type, and then we need to assign a var type into this. What? Yeah. And then that should be fine. And later in here, if we have this, we need to get the value from the allocated global variables and check them. Huh? Did I miss something? So what is the type of this? It's 6. The assignment is 6. And I actually, yeah, whatever. This is the allocated variables, allocated variables. We are getting basically not the identifier, but actually the value that we get from that identifier, which should be inside of the assignment dot var declaration dot name dot symbol, I guess. Cannot What do you mean? Sorry. What do we have? Yeah, so there should be fine. Cannot use allocated as a token value in assignment. Oh, okay. Yeah, so I know about that. So this is the var decl dot assignment dot literal dot int. Yeah, this is a monstrosity. This needs to change for sure. Yeah. Yeah, this is a monstrosity that needs to be adjusted, but I don't fucking care right now. But as you can see, it is working actually. So this right here is inferred to be assigned 64, and when we try to compile it, it is going to type check and it will say that that's incorrect. And if that is the case, just update this, or the other way around should work just fine. Just say, okay, this is U64. And that should work. Yeah. So no problems there. Now if we're doing here this, sorry, what? Oh yeah. U64. Now it works. Great. Oh boy. Nice. Nice, nice, nice. What should I be doing right now? I think I can make it work with strings as well. It shouldn't be that hard. But I do feel like this entire thing should be its own function, because we then can later basically just call it in here, I guess, because we are basically doing the same thing. And this should be its own function as well. And then we have just a single loop that is doing all the work, and we can reference it. Yeah, I think that's a better approach that I'll be doing later. Because what the fuck? What is this? This this is insane. What? Yeah, if you see, this is basically a map of strings to nodes, but we are assigning this to a token. So we get a node in here, and this node is this monstrosity because it's indexed by a string that is a symbol, and this symbol is basically the identifier that we are assigning to a value, to another identifier, and then we get that from the allocated variables that we have, and we get their assignment as a literal integer, and we say that this is the right hand side as a type. I mean, is that correct, I guess? Because it shouldn't be an integer, right? It's a token, and actually I don't think it is correct. What the fuck do we have in here? Huh? Huh? It's not reaching? What? What is this? What do we have in here? So we should have two. So the first one is value. That is fine. The second one so we have an assignment, and then we have a variable declaration. So this right here is what we have in here. This is the assignment. The assignment of that is a variable declaration. Let me, yeah. So this is the assignment. We get the variable declaration of that assignment dot symbol. Yeah, dot name dot symbol. And this is basically what we should be actually using in here, and that is correct. But I mean, do we need to get the allocated variables? Because in theory, you can just do something like this, and then we get the type, not the symbol. I mean, we don't even need this actually. Huh. Yeah, maybe I'm just fucking stupid or something. Because if we remove this, it is not working. Did I do something wrong before? I don't remember. Expected a type. Huh? What is the problem? I don't understand. What do we have here? The second time, yeah, this is the part that is annoying about building a type checker, because it's so many moving fucking parts. So it's S64. Huh? What we have in here? So the type, we don't have a type. Oh, Yeah, we don't have a type in here because we need to infer the type. For identifiers. That's why we don't know this. That's another problem that I don't want to handle right now. We basically, yeah, I got it. We need to check if we don't have a type, which means that we are inferring the type. Basically, we need to get the type from the identifier and provide. We could do something like this. If left hand side var dot type dot token type is equal to token infer. Then basically we need to get the type that is already known and continue similar to how we did in here, more or less. So in here we need to say, okay, this var type is not a token identifier. We need to know the right hand side as well. And we need to say that this is the symbol, right hand side. Then that's it, I guess. We can even do something like this, I guess. We are passing this as a pointer or something. No, let's not do that. Does that work? Yes, it is fucking annoying. We can just say this. And it is in fact working because it is inferring the type from this. So here is the type, here's what it was inferred, and we can even, just for the sake of consistency, or not even consistency, for debugging purposes, we can say something like inferred. It's a boolean, just for us to know when that happens. We can say like inferred true, and by default it is false. And we can even say that in here as well, just for us to keep track of what was inferred or not. Yeah, maybe. I don't know how useful that would be, because maybe this should be its own thing, I guess. Yeah, let's keep this for now. I think we should keep this for now. Sure, let's keep this right like this. Yeah, let's remove this, and now I want to do the same thing, but instead of integers I want to do, and that should actually also that was actually wrong. Let me rerun. So why did that work actually? Because it shouldn't. Oh no, okay, that's fine. I think I had assigned in here. Yeah, okay. That's it. Sure. Now I want to do a string. Yeah, let's start with that. If we do this, yeah, it thinks it is a 4, but it's actually not a 4. We could even say something like, if it reaches the end, it's probably an error. And we don't even need this, we can just straight up say that this is false and should not be reachable. Sprintf unreachable unexpected node, and then we can just say the node type. Node to string, and then we get cs get whatever we have now dot node type. What the fuck? What is the problem in here? Oh, I see, it's because of that. Sure, I can keep it in here just in case, and then I can just say this right here, but instead of the actually, fuck that. And very, very important, I am saying this is a signed 64, but I don't even know what the hell it is. So this probably shouldn't be here. It should be here. I mean, it doesn't matter really. Yeah, it doesn't really matter. Because do we even need to continue in here? Probably not. We just need that in there. And I can just say basically the same thing, but instead of int, it's a string. What? And we reached what is the problem in here? Yeah, let me start with the string. Show y. Yeah, okay, that's the problem. I forgot to continue at the end. So now we do have it, And we basically need to do the same exactly fucking thing, but with a small twist, I guess. Instead of int, it's a string. Instead of s64, it is a string, because the strings are the default value for strings, obviously. We do this. We don't have anything other than strings for now, and I don't know if I will have anything other than strings. That's it. And one thing that I can test right now is just, can I remove this? Yes. And it is in fact inferring the actual type of this thing. And I can even double check it, I guess. Can I? I mean, do I need to do this? I don't think so. Maybe I can even just ignore that. Yeah. The same goes here, I am assuming, because technically we are not looking things up. We have everything in the tree. Now, if we go in here and we say that value d is value c, and we run, I think it should fail. Yes, because we don't... Why? Value d expected a string but got whatever. I mean, I don't think we need to do that. This is not var type. That should work, I guess. No, but I think this is the approach actually, because and if the other things didn't fail, so it is failing because of the right hand side. So what do we have in here? It was inferred. We don't have a symbol. Yes, because this is the left hand side. Right? Wait. When we don't have it, if left hand side, yeah, no, it should be right hand side, and this should be left hand side, I guess. Is that it? What am I doing wrong? We are... I see. We don't need this. Actually, we need to do this. Because that's where we are actually storing this fuck. Yes. Yeah, okay. That was the problem. So it is working as expected right now. Now the thing is, what is the left hand side? Why don't we have this? I don't get it. Huh? This is the same problem. I don't need that. I need this right here. And then just for the sake of testing, let's test this out. What we have, we should have 2, but we don't. No, we do. We do. We have it. D. D was not inferred because we do know about it, but it should be the type it's inferred true. Yep, okay. And let's double check. That is the actual C should be inferred, right? Is that correct? C is inferred, in fact, and D is not inferred. Great. Yeah. Okay. Yeah. Looking good. Now, if I do it like this, it is working. Great. This is looking good, I guess. A lot easier than I expected. But that one thing that is very important actually is that everything that I'm doing right now, it's only should work because everything that I did so far is like a compile time known thing because of the operator that I'm using. This is me saying that this is a definition, a C-like define, and this also this right here and this right here. Now when we have it like this, I think it should still work right now because we are not checking for that, and we can even go into the nodes, and if I go to a node in here, we can say that they are reassignable, and we need to check for that when we are doing that, I think, because that is also part of the type checking. And I think that should be easy in theory. So if we have something like this, we know it is reassignable, which means that this is not a valid operation. At least, yeah. I don't feel like it should be a valid operation. I think I'll start with that. I will start with the rule where this is not allowed if we have something like this. But later with optimizations, maybe that could be allowed. Maybe. Because maybe that is fine. So at least this example is fine, right? Because there's nothing between line 1 and 2. But who knows, when we are actually compiling and we are actually in assembly, things can happen between here and here, so it shouldn't be allowed. Yeah, maybe not. Yeah, let's not allow it. Yeah, let's not allow it. So, and where is at the node level, or is it at the, yes, so at the node level. So let's check it like this. Let's start simple. This is integer, and this is only when we have identifiers, so that should be even easier than whatever I was doing. So we need to get node 1, which is the left hand side, and we need node 2, and node 1 is basically this. This is the node, and this node has reassignable, and then we can just get reassignable. Then we need to get this right here, right? Because in here we have reassignable as well. Assignment is reassignable. And the thing is, if they are different, it's basically an XOR operation, I guess. What I mean, this plus this is not allowed, this plus this is not allowed, but this plus this and this plus this is allowed. So basically we have an XOR, right? So if XOR this, so what we can maybe do is if and one, how do we do XOR in Go? Like this? Is this allowed? How do we do XOR in Go? So apparently no. We don't have any kind of bitwise XOR operation for booleans, which is a shame, I guess. We don't have a default thing for that. So let's do it the old way, I guess. XOR Yeah, okay, XOR. It's gonna be basically N1 or N2, right? And yeah, and not this and this, right? Is N1 or N2, and not this and this, right? I think so. Let's see. Nope. Or yeah, it is. So we just need to negate that. Right? So in this case, we need to assert false or something. And now if we do it correct, yeah, let me remove this because that's incorrect. If we do something like this, that should work. Yes, it does. Otherwise, we can just say like invalid operation cannot the thing is, actually, the thing is, it's a little bit more complicated, because we can do this, we can do this, and we can do this, but we can't do that, which is basically and. So if we have this and that, we fail, but otherwise that is fine, which makes things a lot easier. So if we do this and that, that should be fine. So this is fine. This is fine. This is also fine. So if both of them are reassigned, if N1 and 1, if not N1 and that, is that it, I guess? And now if we do like this, it shouldn't work. Yes. Okay. Which is better? So we can say that cannot assign runtime value to a compile time. Yeah, sounds good. And if we try to run it, it will fail. Invalid operation cannot assign runtime to a compile time value. Okay, looking good. Now, we have most of the things, I guess. We do have this, we have strings. I think I will include the operation for booleans, I guess. So value e, and now it should fail. Oh, what? I think I don't have it. Oh, wait. And this is on the line 395. No, wait. This is primary expression. I want expression. Parse expression. Yeah, that's the one. Token. Oh, okay, I don't have it actually. Let me include it. That should be easy. Instead of token string literal, this is a token boolean literal. And instead of this, we do that. And instead of string, it is a boolean. And that should work. Yeah, let me go back. Yeah, so if we go to type checking right now, we should have another one specifically for node integer. Wait a second. Am I doing that? Yeah, that's incorrect. Yeah, now it is correct. And it shouldn't run. Or fuck me, I guess. Oh, okay. Yeah, I'll fix this later because yeah, whatever. So instead of integer, let's have a boolean variant for this. So boolean, and instead of string, it's boolean. What the fuck? And instead of that, we would have bool. And we only allow booleans, we don't have other values for true and false should be inferred, I guess. And that's not what I want. What the fuck? Where is it? Where's the... I don't want this. I don't fucking care. What is the node for this? Huh? It's not reaching? No, yeah, because it's in here and it's not integer, it's boolean. And I just noticed I made a mistake. Instead of integer, it's a string. And did I remove the... Yeah, so I... Instead of the value as expected, the type whatever, and the value b, I guess, I don't remember which is the name for... It's like C, I guess, I don't remember. What is the Golang printf bool? I don't remember. It's T. So it is the T, and then we have a string in here. And I mean, we can even value this. It should be, must be string. Value whatever, must be whatever, because we don't allow anything else for now. And then we can just print let me just print the actual node that we got, and it is indeed a boolean. Now if we do value f as value e, it should also work. So here's the value e, and if we go in here and print the actual node, what the fuck? Huh? Did I do something wrong in here? Did I forget anything? Oh, sorry, my bad. So inferred false, but in here inferred true, it's a boolean. Great. And now this works because we already have that set up. But if we say something like a string, it should fail. Yes, expected a boolean, got a string. Nice. Okay. What else can I do? Something important. Yeah, that's another case which is very annoying, and I don't want to handle it right now, I guess. Because what I was thinking, not initialized variables. Because we need to look them up in my allocated variables and procs and whatever. It's kind of trash right now. And I don't want to handle that. So fuck that, I guess. And I think I will just do a small break because I am streaming for almost 2 hours, 2 hours and almost 30 minutes. So yeah. Yeah, be right back. Hey guys, I'm back. So what do I want to do right now? Hmm, I, I think the first thing that I'll do is just commit all the changes that I did because they are quite big and a bunch of them I don't really care about. Yeah. Let's say introducing a proper type checking for okay. So it should be here working. I just want to see the changes actually. So, Jesus, that's so fucking small. Close that. Yeah, I removed that. I made. Yeah, this is now a function, not a method, because I didn't like the way it was before. I included booleans because I forgot to include that previously. I changed this to the slice that I created. Okay, created. Okay, returning that as expected. We are passing every. Okay, I see. We return the slice and we need to. Yeah, probably I need to change this later because for the sake of consistency, I mean. But yeah, whatever. I disable debug because I don't fucking care about it right now. I created a comparison function for node and node types. I created an assert, consume and assert thing for. I created one function to assert that I am passing the correct node types given the node that I have. And then I changed basically whatever I had before. So I introduced one helper function that generates the types as tokens that I then can use in the type check. And I mean, I don't even think it needs to be just literals but whatever. And then I am looping all of them. So I am matching and I am consuming them. Sure. If they are identifiers, we double check to see if that makes sense because they cannot be. We cannot assign a runtime value to a compile time value. We are checking them and we are inferring the type if we don't know about it. Then we are basically we are type checking now, and this is what we have on the left hand side and the right hand side. If not, this is the error. Otherwise, we have a bunch of literals with default values, and here we have a few that are allowed if we want to, which makes it easier, I guess. String literals. Eventually, I will have a character type thing, but not right now. If it is a string, we do this. If it is this is an integer, this is a string, this is a boolean. And then we continue, and there's an unreachable here. And here are a bunch of the examples that I commented out. Okay. Now that we have that done, maybe I can work on what can I work on in the type checker. Maybe function calls, I guess. Yeah, I think so. We can work on function calls and like this right here, maybe. Should be very interesting because let's start slow. Let's not care about the return type and assignment of that. So what happens if I try to run this? It fails. Unexpected token identifier. What? In the AST. Why it is unexpected? What is unexpected in here? Sorry. Is that it? Okay. But if I have something like this, it works. So let me go to parse expression, because I kind of know the problem and I need to fix it anyway later. So this is here. Basically, I need to copy and paste whatever I have in here. I guess. Because this is the expression. Because this right here is a statement, but it can also be an expression. If we do something like this, this right here, this is a statement, but this right here is an expression. But if we remove it, it is a statement. Give me a minute. Yeah, so it works as both a statement and an expression, and I don't have a separate function, I don't have a separate parsing for them. I am basically duplicating whatever I have, and this is whatever I have. So if I go to statements, I guess in here, primary expression, we have a whole thing just for calls. This, where is it? Yeah, not this. Open parent. Yeah, this is the thing that I have. So let me do the following. Parse expression. I need to go in here to compare whatever the hell I have in here. So open parent. Actually, before that, do we have the identifier already? We don't. So what am I doing here? Token open parent, but it's not only the token in here, we have the identifier, so it should be token identifier and token open parent instead. So token no identifier, so this is token identifier. We consume the token identifier, we consume open parent, then we check to see if it exists, otherwise it should fail. Sounds good. And while it is not a closed parent, sure. If it is a number, sure, we do this. If it is a string, we do that. And if we have a comma, we get the comma. And we basically consume that comma and then close semicolon and close parent. Yeah, because this is a statement and it is expected to be. So now it should be working, I guess. Unexpected node call. Yes, exactly. So it is working right now. If we go back to type checking, instead of checking for identifier, we are checking for node call. And this is node call. Oh fuck me, what the fuck? Node call. And we can basically just say reach, just for the sake of testing. Yes, it is working. Now we can consume it. We consume the node, and it is a node call. Why? To do any, and this is the node, I don't care, just give me yes. Okay. And actually I can even do something like chaos debug args, just for the sake. So it is in here, the call. The thing is, and this is very important, I also need to get the proc definition, which is located in the proc allocated procs, which is in here, I guess. Allocated here. So first things first, I need to know the proc name is basically no.proc no call dot name. This is the name, and now we need the actual proc definition, and this is the allocated procs at the proc name dot symbol. And we can even say this is directly this symbol because yeah, it is easier. And we can even double check what is this, just to make sure it exists. It does in fact exist. So we have a bunch of things in here. We have a scope, we have inputs, and we have outputs, and for now we don't care about that, but eventually we will. Now, what do we need to check? So right now we need to check each argument that we are passing in the call. If it is a literal, then if this literal is matching the expected type, or if it is a identifier, that should also work. So we can even proc call just to make it easier. Proc call. So we have proc call and then proc definition. We need to do the following. How do I want to do that? Because this is basically a nested loop, kind of. Because we have two lists in order and they should match. But I think the source of truth, the first loop should be the proc definition for inputs. Because we don't have anything that is like optional and we don't have anything that is variadic for now, so I think it should be easy to just say, okay, yeah, let's try it. First thing that we need to do is match the length, the arity, I guess that's the word that I'm looking for. The arity of the function definition and the function call, they should match. And maybe this could be something that is already defined previously when we are doing the AST. So if we go to AST and then we have the call, we don't have arity in here, so we could have arity as an integer or something, and then proc, we can also have arity, I guess. Just for us to check that they match. Because we could have what I'm thinking. Yes. For now, let's keep it simple. Because later the idea is for us to have optional fields. So if we go into maybe like, I don't know, a string or something, or maybe even async.chaos, I think I have it. So the whole idea is that eventually we can have values with arguments with default values, which impact the arity some technically, but maybe we can just split them into like mandatory fields and optional fields and whatever. Sure, let's keep it like this for now. So since we are doing this, we need to have arity. So proc parse proc definition, proc definition, parse proc definition. Arity is 0 for now. When we are parsing the inputs, it's in here. Basically, we need to increase the arity of that. So after we append the input, we need to do like no.proc.arity ++ I guess, and that should be fine. And then in the parse expression, when we are looking at the actual call, so in here we have number and string for now. After we done it, it is not a node in this case, it's left hand side if I'm not mistaken, and it's not proc, it is call, so left hand side dot call. And the same goes to primary expression when we are talking about this, which is in here, but in here we are using a node. And if we do it, we can see the arity. So it's 2, the arity. Nice. So in the type checking, the first thing that we need to do is make sure that the arity is matching. So proc call dot arity, right, is equal to proc definition call arity. And if they don't match, you can just assert false. I guess we can have a better error message later, but we can just say that fmt as printf the function whatever expected this number of arguments but got this number of arguments. Or something. And then we can just say like proc name and the different arities. This is the first one, this is the second one, because this is what we got. Just make it a little bit readable. Let's just, fuck me, I guess. And if I go into the actual file, not the binary, not in the binary, but in here, and I don't provide one of the arguments for that function, it should error out. It didn't. Why? Is it even reaching here, or is it failing before that? Okay, it did reaching. Yeah, okay. That's the reason. Sorry. No, it isn't. Fuck me, I guess. So let's enable debug to double check what the fuck. Null pointer, love it. and this is line 35. Yeah, it's because this is not a proc call, this is a is it not? Oh right, it is. What is this? Yes. Oh yeah, because it's an assignment and I forgot about it. It's that should be working then. Yes. So why it didn't like it? Huh? So this right here, what is this? Arity proc call. Yeah, should be working. Did I do something silly? Huh? Not proc call, proc definition. So it is true. And this should be also 1, and it should be false. It is. Oh yeah, no, this is should be if not equal, because yeah, that's why. $42. Yes, because I'm giving the wrong thing in here. It is not a call, it is a proc. And now it is working. So let me go back into here, disable this because I don't care about it anymore. If we run this, function something expected 2 arguments but got 1 argument. Nice. Now if I pass another argument, it should be good. So the first check, it is working. Now we know the arity is correct. We need to match using the proc definition inputs. So we have in here for whatever input, we get this inputs, and basically we need to make sure that it is what we want it to be. Yeah, range. Yes, input 1, input 2, and then we have that. Nice. And then what we actually can do is check that the inputs for both of them are matching, and if not, it is a failure. And it is nice because they have the same amount of inputs because their arity are the same, so we don't even need a double loop for now. We can just use ID for now. So yeah, we have the index of the input, so that should be fine. In other words, we can just do it like this: proc call dot inputs, add the index, whatever must be. Now wait a second, what is this? I don't remember. Proc call. Sure, we don't care about it for now. So we can get that by the literal that is annoying, but we can work with that. We just say this is the input, this is the argument. If we can cast, actually yeah, we can do it like that. If we can cast this into a string and we get the input dot literal, can we do that? I think we can, because we know. Actually, let's make it a little bit different. If node type input dot node type is equal to node string literal, we know it is a string literal, and then we can just cast assert this into a string and we get the actual. I mean, we don't even need this, I guess. If it is, then we know the type. We can just say make type list, and we have yeah, whatever. For now, that should be fine. It is a string literal because we know the type, and we can just do that for int literals as well. Int literal. Now if it is, then we need to double check that the proc definition dot proc dot inputs at this index, and then we can basically just print this because I don't remember. Sure, whatever. For now, let me just ignore this. Fuck this language. We need to get the variable declaration and then the type. Okay. So if we get var declo dot type, that should be fine. And then we get a string and a signed 64. We can do the same in here, I think, but it's not like that. So this is basically 2 and 2. Why they are both 2? Did I do something wrong when I am actually primary expression literal in? Yes, it is wrong. And then parse expression, is it wrong also? It is wrong. That's why it was not working. Fuck me. So now that we go, where was it? Yes, here it is. So we can check, yeah, we can check that as the input in here. And then if the input.node type is equal to node string literal, we know what the fuck it is. Fuck this, fuck this, fuck this, yeah. If we know it is a string, basically we need to make sure that this right here is also a string. And what I think I'll do is make type which is similar to the one below, but I don't need to loop anything. I can just return a token that is token type token identifier, and then symbol, it is just the type of the symbol, and that's it, to make it easier for me, because I don't want to instantiate a bunch of tokens all over the place. Not type, not expected. Type is basically make type, and the type is basically string. Symbol is equal to whatever we have in here. And if it isn't, we can basically just say that these how can I do that? First, let me assert this and we can make sure it is working. Assert false, whatever. So it is in fact working, but if I go here and I basically just remove this and I say this is 1, reason not provided, okay, because it was expecting string but got a signed 64. Okay, so what we can do is basically say the function whatever expected this as a this type for this argument but got this type or something. So we have proc name, then we have expected, and then we get the type, which is expected type dot symbol for, and this is the actual argument, I guess, and we can basically say that we can probably just use argument in here and replace and say that argument dot proc dot input or something. No, this is just proc dot var declaration dot name. Expected this, but got this monstrosity. I think that's it. Okay, yeah, sorry, my bad. As printf like this. So it is fucked up. Function something expected string for, and then so wait, I hate this. Later I need to make something a little bit better because it fucking sucks. This is the symbol, this is the name, this is the yes. Yeah, the function something expected type a string type for input 2 but got signed 64. Okay. And now the other way around, we can do basically the same thing. Later this needs to be actually improved vastly, but no. Expected. So here is the thing. If it is I think we need to change later probably how we are handling literal nodes, because we do know their type and we don't probably need to infer them if we don't. Let's do the following. If we go in here and we parse expression, so we do know their types at this moment because they are literals. So we can basically just say that, yeah, the thing is, we don't know. This is not a thing on the expression, it is something on the actual statement, which is annoying. Because at the level of the statement, if we go back, we know the type of the thing, basically. So parse statement. So in the primary expression, we kind of know, depending on the information. And one thing that maybe we can do is separate everything, in the sense that we call it first and then we do the assignment, because after the assignment we know the type, which can be easier maybe, and we don't need to infer anything later. So if we know, we don't need to infer it in here, I guess, because it's already inferred. Let me think about it. So in here we don't need to do anything because this is a reassignment, but in here we have identifier and column, which means we have a type, so we don't really fucking care. I mean, we kind of do actually, because we are inferring it in here. Yeah, so this is the thing, right? We are kind of inferring it already, which is kind of useless actually. It is kind of useless because we have in here we have an identifier, meaning this is a type. So in here basically we have like this. Right, we are basically looking first for an identifier. Where is it? We look for identifier and column, and we have it in here. After that we are looking for, if we are, yeah, so if we find it, we go into this loop, we consume the identifier, we consume the column, we are saying the type of the node, we are saying that it's reassignable for now, and then the declaration of that, we are saying that we have the identifier, right? And then we are inferring the type, which is not useful, I think, because we can get that information already after we parse the assignment. Whether it's a compile time assignment or a runtime assignment, we know it. Which maybe we can do it like this. We don't have it. We are basically assigning the name for the node. Yeah, we are saying this is the name, which is basically the left hand side. We are not initializing it yet. If we do find the identifier, which is basically this, that's okay. Assign that type to that. Yeah, assign that identifier to this type. Now, if we find a semicolon, that's it, return. Great. If we have an assignment, which means that we have this or this, both of them should work, we we will say that they are initialized or not and reassignable, sure, but we can also say, so yeah, okay, let's do the following. Let's go back. This is token infer, and in here, in addition to initializing anything, it's not in here that we are parsing the expression though. Where is it? We parse the expression in here. So what we can basically do is, instead of that, we get the expression, we know the expression in here. Let me comment this for a while, for now. We have the expression in here. With that expression, if it is token infer, so node.var_declo .type is equal to token infer. If we have something like this, Now is our chance to infer the type because we kind of already know it by the type that we have in here, given this node type. So in here we can basically say if expression.node type is equal to node integer, we already know the type of that because it's basically that. We know that, which we can already assign in here. Yeah, I think that's it. And then we can just say like, okay, in here, instead of this, we have the type, and the type is basically token. We can say make token, make a type, and the default value is signed64, and that's it. Yep. I think that's it. And we can even then just say that this is the expression. Yeah. Okay. Otherwise we have node type equal to node string, I mean, and basically just say this is the default value for a string. Otherwise we have something else for boolean literal, and it's bool. And we no longer need to infer the type, at least for now, for literals. Later, probably when we have structs, it is going to be different because there's a whole thing for structures, right? Yeah, okay. Which means that we can probably remove a lot of the things that we have for inferring on the type checker, because we are kind of inferring things already on the AST level. Mismatch. Yes, sorry, this is not token type. Yes. Node.type expression dot. Yeah, no, getting the wrong thing. This is not a variable declaration. This is the node type that I care about. Fucking Neovin. What? What is happening here? Yes. Yes, that is correct. Okay. And now it is working, and maybe if we even go back to the type checker, we don't even need probably. We do need for this, I guess, but not for literals. So I would assume this right here is completely useless right now. Which makes a little bit more sense. Yes. And if I fix this back, it should no longer fail. Wait a minute. Why though? So it is saying that it is expecting string when it is yeah, it is, because it's wrong, that's why. And now I don't even need this, so let me actually clean this up, because now it should be working. Yes, it is. And instead of creating a new type, I don't need it because it's already inferred on the previous step. And now what I can basically do is, actually let me fix this, because otherwise I'll be not cool and I hate this. So this is the input, this is everything else. The expected type is actually no longer something that we are creating, it is something that we can get. We can get that from the actual call. Yeah, I think that's it. So let's take a look. Calls, input. Fucking language. So this is the argument, and it is indeed sorry, not the argument, I mean, wait, what? Oh yeah, because this is not an actual yeah, this is not an identifier or anything, this is just I'm thinking about something else. I think I'm tired already, so let me just clean this up in here, because no one fucking cares. But now, just for the sake of having something working, I will just hard code this to OS64, because this is what we have today. And this is not a string literal, this is a literal. And this is, yeah, that should be fine, I guess. And then after that, we basically are done, I guess. We can finish it with a continue, and it is working. Now, it is not a great solution, because if I go in here and I say, okay, this is no longer a sign 64, this is a use sign 64, it will fail. Because the thing is, I am not treating this as a node without a identifier. So how it works today, when we have an assignment to whatever, we are creating a node, right? And this node has a name, a type, it has an assignment, they have a bunch of things, even yeah, so they have a bunch of different things in here. Inside of assignments, we have even other nodes, so we have other nodes in here. And when we assign something, we basically have it as a, and we have some type, for instance, like a string. And then when we are assigning, we can have another value, like value e or something, and this is considered another string, another node, which we would have like a name also, and so on and so forth. this is how we treat assignments. This is how we treat these statements. But these single values that we are passing to a function, they are not considered assignments, or they are not considering nodes. They are basically just, I don't know how to say that, they are orphan values or whatever, because I can even go back to the AST in here. If you take a look at parse expression, they are basically like a node without a parent or something. They are childless. I have an idea. They are parentless, I guess. I don't know. Which makes it difficult for us to keep track of the different types that it can have. And basically, probably I would have to hard code it, because, you know, numbers can be any type, and we would have to basically infer the type from there. Something similar to what we have in here, where we have a list and we can type check literals for them. We can try to have something like this. I mean, why not? Where is it? It's in here. So we have it here, and basically we need to do the type check here, and if they don't match, so instead of having like the expected symbols like I had before, I just need to pass the one symbol that I know it is, and should work, I guess. Yes. Let's see. Undefined, yeah. Expected type. And then we can just say function as expected, integer, signed or unsigned integer type for whatever, but got that whatever. We are not concerned about messages right now. Cannot use proc blah blah blah. Okay. Not a symbol, it's the type that it wants, and it worked. But if we provide a string in here, it should probably fail, because we are expecting function expected string, but got, what do you mean? Function something expected string type for input 2, but it didn't actually. It expected unsigned integer. Huh. Input. Maybe not the input we are doing this. It's the actual argument. Yeah, because the thing is, yeah, that's the problem. Yeah, there's probably a better way for me to do that, because this is so fucking annoying. I don't really know what to do right now. We need to, so this is the definition, this is the call, yeah, basically we would have to have it like here. We would have to duplicate this. I would assume, which is kind of annoying. Yeah. So this should be its own type checking sequence of things, which is annoying. Sure, for now let's keep it that way. Because if I now go back, it is working. It isn't actually. Huh. So if it is I think we should be able, I think we need to do a little bit differently. We should continue, yes. No, it doesn't make any fucking difference. If we have, what do we have? So this and this is the input, this is the actual thing. It is a literal integer. It is. So if we have the argument, because this is the argument, and the argument no, it should be the input because we need to match that. So the input should be a node string. Yeah, this needs to happen first. So this is in fact expected to be a string. And then we have the actual argument that we are passing. That argument is in fact this is the actual argument with the variables that we are expecting. So if it is like this, argument dot var declaration dot type So it's two conditions. We need this to be a string literal, and this right here I mean, this is yes. They need to match. So if it is, then that's okay, we continue. Otherwise, we fail. Mm-hmm. Mm-hmm. I don't know. Se não for, if it is not like this, yes. Yeah, I'll continue to work on that later, I guess, because I'm just tired. And I don't want to think about it right now. I am indeed really tired, and it's late for me. So yeah, I think I will end the session for now, because this is more than what I wanted to do. It is already working, so we did quite a lot actually. So this right here is not an actual good example, because it's the middle. It's a work in progress thing. But one of the things that we did is basically, so now what we can do is we can specify values. So we have here a new variable it's a new variable where we are assigning 10, and this is a compile time value that is inferred to be assigned 64. We are assigning that value to another value, this identifier to another identifier, and we also can specify types. So if we want to have a compile time value that is unsigned, we can. It is going to work. The same goes for strings and for booleans. Okay, if I run this, it should work just fine. Yeah, we can even check for the exit code. It is great, it didn't fail. So we can make it fail if we say something like this is a S32, and then if we run, it should fail, but it didn't, because fuck me, I guess. Yeah, it didn't fail because it's inferring the type, but if we do sign 64, it will fail because it is expecting something, but otherwise it infers the type. So if it is a sign 32, this will be a sign 32 as well. So you can look, it is working. It also works for variable, for strings, if I'm not mistaken. So if we say something like this, it is not going to work. The value whatever must be whatever, so this is not correct. And if we say something like this, it is going to work. Now the same goes for boolean. So here we have true, and we are assigning true to here. But if we say like, okay, this is a boolean and we are saying value C for whatever reason, it will fail because it is expecting boolean and got a string. And now the cool thing is that because we cannot assign a runtime value to a compile time value, it is going to fail. So this right here is something that can change over time, over the actual run of a program. So it may fail. I mean, it may change, and because of that, it cannot be assigned to a variable that is known at compile time. So this right here will also fail. It is an invalid operation. So yeah, but we can do the other way around. We can say that a compile time variable is assigned to a runtime thing. So if we do this, it should work. We can assign a runtime variable to another runtime variable, so that should be fine. And yeah, we did quite a lot today. And yeah, the idea now is to continue working on the type checking. I need to look into a little bit better how to do this. I will work on that because it's kind of annoying right now how it is structured. I need to separate them to make them less what is the word? It is less noisy because there's a lot of repetition in here. But yeah, I think that's pretty much it. Thank you very much.